Hello all, welcome to AI Educator. In this video, let us learn about weights and bias. Weights will define the strength of connection between the two neurons. In other words, a weight decides how much influence the input will have on the output. Weights can also be defined as the priority of the connection. Weights are random integers assigned to a connection where range of weights will be the range of activation function used in that layer. Let me give you a small example so that you can understand it better. Imagine yourself trying to touch a hot object like a burning candle. Then your brain will send a signal to your hand that not to touch it. The signal will have a high priority because it is important not to touch a hot object to avoid hand burns. In a similar way, the important connections will have a high priority or a high weightage. Now, let us discuss about bias. Bias is a constant which is an additional input to a neuron along with the cumulated sum of input and weights. Bias always has a value of 1. Bias guarantees that even when all the inputs are 0, there still will be an activation in the neuron. Now, let us see the weight notations. Let us consider a neural network with an input layer with 4 nodes, 2 hidden layers where the first one has 3 nodes and the second one has 2 nodes, and an output layer with a single node. In general, the notation of weights will be something like Wij, where I is the layer where it is present, J is the index of the node where the connection is coming from, and K is the index of the node where the connection is going to. Now let us see how do we do it. Let us consider this node and connection going to all these 3 nodes. How will we notate those weights? First, let us see the connection between these 2 nodes, which will be this one, and it will have a notation of W111 because it is coming from the first node and going to the first node. Now let us see for these 2 nodes, which will be W112 because this is the weights of the first layer and it is coming from the first node and going to the second node. Now let us see the connection between these 2 nodes, which will be the W113 because it is coming from the first node and going to the third node. Now let us look at this node. The connection going from this node to this node is W121 since it is coming from the second node and going to the first node. In a similar way, W122 coming from the second node and going to the second node. In a similar way, W123 coming from the second node going to the third node. In a similar way, let us look into these connections, which is W131 coming from the third node going to the first node. Now, this one is W132 coming from the third node going to the second node. In a similar way, W133 coming from the third node going to the third node. For the last one also, it will have the same W141 coming from 4 going to 1, coming from 4 going to second, coming from 4 and going to third. In a similar way, we will have the connections for the next layers also, which will be the connection between these two is W211 because it is in the second layer of weight. In a similar way, W212, the second layer coming from the first node going to the second node, W221 from the second node to the first node, W222 coming from the second node going to the second node, W231 coming from the third node going to the first node, W232 coming from the third node going to the second node. In a similar way, W311 because it is the third layer of weights, and coming from the first node going to the first node, W321 coming from the second node going to the first node. So this is how we do the notation of the weights. Now let us see how do we update the weights and bias. To update the weights, we use a formula, that is W new is equals to W old minus eta of dou L by dou W old, where eta is the learning rate, W new is the new weight, W old is the old weight, and dou L by dou W is the rate of change of loss with respect to weight. In a similar way, we will be also updating the bias with the help of a formula where B new is equals to B old minus eta dou L by dou B old, where B new is the new bias, B old is the old bias, eta is the learning rate, and dou L by dou B is the rate of change of loss with respect to bias. In the next video, let us learn about the optimization.